In Lesson 3.3, students explore how the gravitational pull of various celestial bodies in the solar system can impact the weight of a can of soda. The lesson begins with the teacher introducing the vocabulary terms radius and diameter, as well as reviewing the term gravity. At this point in the lesson, radius and diameter may not have much significance for the students. However, later in this lesson, students will observe how, by measuring the radius, we know the distance from the center of a sphere to its surface. And they will later discover that this distance from center to surface is a factor that influences the force of gravity on each planet's surface. The lesson plan provides a partially completed graphic organizer that the teacher can fill out with students to spark discussion about the factors that may influence gravity on different planets. Students should intuit from the graph that a planet with greater mass should exert more gravity than a less massive planet. Students are then given a brief reading handout that describes what a person would weigh on Jupiter. The mass of each planet is discussed so that students understand that while all planets are massive, some are much more massive than others. Students also are introduced to the concept of gravity factor of a planet, which is the comparison between that planet's gravity to the gravity we experience on Earth. With this understanding in place, students are ready to measure a set of 10 soda cans to represent the 8 planets, also Pluto and the Moon. And these 10 soda cans will need to be labeled and prepared ahead of time, and they'll be prepared to each weigh different amounts. When I was setting up cans for this lesson, I found that just adding water to the cans is sufficient to get the desired weight for every can except Jupiter. As you can see, Jupiter is so massive that our model soda can needs a lot of weight added to it. When I was setting up this lesson, I filled the Jupiter can to the brim with water, and then I added 30 large washers on an aluminum wire to get this can to the target measurement of around 8.5 newtons. Gravel is also provided in this kit as a means to add weight for this activity as well. So you have some options for how you want to set up your cans. Students in small groups each receive a can and a spring scale, and they use the scale to measure how much each soda can weighs. After they record the weight of the one can, the groups will rotate and weigh the next can in the sequence, and they'll do so until all groups have measured all the soda cans. Since elementary spring scales may not be extremely accurate, the teacher in the lesson plan also provides us with the precise measurement weight of each can, and these exact figures could be written on the whiteboard as a sort of number bank for students, so they could try and match each planet's soda weight using the more crude measurement, and then they can match that to the more precise measurement that's listed on the board. Ultimately, by the end of Lesson 3.3, we want students to have a hands-on experience with the different weighted soda cans so they can better understand what it means to have different weight measurements due to the gravity exerted according to each planet's mass. These measurements will be carefully analyzed and interpreted in the following lesson. Lesson 3.3 requires 10 empty, identical aluminum soda cans to be obtained and prepared ahead of time. All other materials are included in the kit, and all charts and graphic organizers can also be found in the lesson plan for Lesson 3.3. Make sure to hold on to these soda cans for the following Part 2 lesson, which follows in this kit.